Determine the domain and range of the function da 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 if a is positive and b is positive. Well, I find this pretty hard to work with, so let's put some actual numbers in here. A is supposed to be a positive number and so is b, so what if you have like y equals 2 root 3x? What will that do to the domain and range? If you start with root x, you've got a half parabola that looks like this. Now we stretch it vertically and we compress it. We're going to get a shape more like this. When you stretch it upwards and squish it in towards the y-axis, you get the same curve, only it's more extreme. It rises more quickly. That doesn't do anything to the domain or range, though. It's still going to be greater than or equal to 0 in the x direction. All of these should contain x as an element of the reals and y as an element of the reals, but I'm going to trust you to remember that so I don't have to keep writing it every time. And in the y direction also, the curve starts at 0 and covers every number above that, so that didn't do anything to the domain and range. Now, if a is negative but b is still positive, they're giving us something like y equals minus 2 root 3x. What happens to our curve now? If your generic root is like so, this one has been horizontally compressed, but we've seen that doesn't do anything to the domain, so who cares? Then this minus 2 means it's been stretched vertically, which again doesn't do anything to the range, and reflected across the x-axis. This negative sign is actually a big deal. It changes the curve to look like this, upside down. So, what effect does that have on the domain? None. It's still... I can't stop writing it. I'm conditioned. It's x is greater than or equal to 0. And for the range, now we get, it doesn't exist for any positive number. It kicks in at 0, and then it covers every number below 0. So y would be less than or equal to 0. Then they say, how about if x is positive? So we have y equals 2 root, but the b is negative, so we have something like this. So now, there's our generic radical. We stretch it vertically, which makes no difference. We compress it horizontally, which makes no difference. And this is a left to right reflection, or a reflection across the y-axis. It gives us a curve which is actually more like this, off to the left. This finally affects the domain. Now our domain is going to be x is any number less than or equal to 0, because the negatives work, but the positives do not for the red curve. And for our range, we get the same range as always. Y is greater than or equal to 0, because the negatives don't work, but the positives do. And finally, what if we do both? What if we have y equals minus 2 root minus 3x? Here's our vanilla unmodified radical. Now, ignoring the stretches, which we know don't do anything, this is reflected across the x-axis, which gets us to about there. And it's reflected across the y-axis, so we get to here. We get a completely backwards radical that goes down and left. So now the domain is going to be all the negatives and 0, but none of the positive numbers. So x is less than or equal to 0. And for the range, again, we get all the negatives. There's nothing up here in the positive land. This curve starts existing at 0, and it exists for all the negative numbers after that. So y less than or equal to 0.